Hey, folks. All right, my name is Martin Olste. I'm the CTO for Cloud and AI at Trellix. And we're going to talk a little bit about AI, the dangers, and some real-world stuff. And the fun part is going to be I have AI-generated images throughout. Some of them are pretty funny, so stick with me. All right, a little bit about Trellix. Who are we? We are Living Security. We are the combination of FireEye, if you know FireEye, and McAfee brought together to create a new company. Our core values are awesome. They're open, tenacious, curious, and fun. And love working there. All right. So first of all, let's do a quick level set on what is generative AI. We've all been talking about AI for a long time. This is a little bit different. This is generative AI. So what do we mean by that? So this is a diagram showing what they show on Stephen Wolfram's site. It's a great description of how it all works. There's a lot of math involved. It doesn't really matter. Essentially, you have things bouncing around, and you get an answer out at the end. And this is really what has changed. Previously, we had more training. You think of machine learning, and it would be AI where if you tell it enough stuff, eventually it'll learn the right and wrong way to do something. This is, you tell it the internet, and it knows the internet. That's the right way to think about this is, if you asked Wikipedia anything, what would it say? So that's cool. What does this really mean? And this is the part that I still, having been studying this for a year now, don't understand how it does this. So I don't know if you can read that, but it says, given the events with the IP addresses in this source and this CSV file, so that's CSV, were any IP addresses malicious? How in the world does it know how to do this? You haven't trained it on what's malicious or not. So two interesting things happen here. One, it understands CSV inherently. It just knows what CSV is. It knows that these are events because you told it. And it correctly identifies that, you know what, this IP address was malicious in the events that you just gave me. This is without training. This is just knowing the internet. The internet knows that that IP address was malicious. And it's really hard when we think about going from what we saw on this model and a bunch of things bouncing around to I understand a CSV file and I understand all of security. That's pretty nuts. So OK, what does that mean? We're in a new era here. So we can do a lot of things with this. As you just saw in the last presentation, you can do things like creating playbooks. You can create emails, and the bad guys do a lot of that as well. You can create images. A number of the slides here at the end are going to have AI-generated images, some of which are pretty funny. Create software, so you've seen it do coding. You can even do things like microbiological engineering. So the amount of academic data that goes into these is really interesting. So a ton of different stuff that you can do with it. This is not the AI that we've been talking about for 10 years. This is generative AI. This is totally new. OK, now with that, because it's new, not everything goes to plan. There's things that can go wrong. And this is the OWASP top 10 for LLMs. That's large language model. You can use that interchangeably with generative AI applications. And these are the 10 things that essentially you have to watch out for. And critically, some of these things you have to watch out for even if you're not using generative AI. So it's still relevant to you. You can go to the OWASP site. They cover this extensively. I'm going to go through some specifics and some specific use cases. All right, so image number one, I asked stable diffusion, prompt injection. This is the image it came up with. I'm like, OK, I guess that's a prompt, and I guess it's injecting something. I thought it was kind of funny. So throughout these, you'll see sort of what AI thinks of the topic itself. And the example here, if you think of SQL injection, you know, put a semicolon or two hyphens. This is ignore all previous instructions and then do whatever I tell you. So again, it's a very human level. It just says, you know, with this plain English, ignore all previous instructions. And if someone didn't code that incorrectly, it will, if they had a prompt template, ignore the first part of the prompt template and then just do the second part. So this allows direct input. You can bypass a lot of stuff. And this is a really big challenge because SQL injection, you can use things like regular expressions to kind of figure out what's going on. This is much harder with large language models because it's just text. All right, so number two, insecure output handling. So can we trust that the LLM is going to actually generate something that is safe for consumption? You can see that stable diffusion doesn't spell very well because it's not about text, it's about images. And so when it put all the images that it's ever heard about output together, it sort of kind of got it right. It's a little mutated, but this is what it thinks insecure looks like, which I thought was kind of funny. So an example, an attacker asks for JavaScript in a cookie. and the LLM responds with the script that is actually dangerous. So it can do that. It knows how to code, and you can tell it to code me something malicious, and it will happily create malicious JavaScript that you can drop that in there. If you had that hooked into a web page where you thought, oh, I'll make a playbook easier for a customer. If the playbook spits out something that's malicious, an attacker can use that to say, oh, run my playbook. It comes from a trusted source, but actually it's got something malicious in it. And once again, it's very difficult to figure out what the output is because you basically need an LLM to police that. All right, training data poisoning. This one, I had to change the image a little bit. The prompt was more around card tricks because training data, first of all, some of the LLMs will not allow you to put in the word poison because that's a bad word and it's restricted and it could generate something. So the different providers have different restrictions on what you can do there as a leading example of kind of where LLM security is today. So couldn't use the word poison, so I used card tricks, and that's what it came up with. But I thought that was a really good example of where the current state of LLM security is. Basically, it's on the input side right now, as in don't prompt for something malicious because we have no idea how to do the output side of it. So in the training data, this is where even if you're not using the LLM, you may still be susceptible to it. Basically, an attacker can go out and let's say create something on Reddit that's malicious. And then, instead of like just a Google scrape coming by that shows up in a Google search result, this is an LLM that months later will be using that data to train. And so you can poison it by saying the wrong thing a lot of times. You can think of this as a disinformation campaign at an LLM scale is the way to think about this. And so the challenge here is that the purpose-built models are going to be especially prone to this. So if they're looking at, I talked about microbiology. So if an attacker went to some of the key forums for microbiology or even infiltrated some of the official texts that are posted there and way, way, way deep down in there put some malicious code, that could show up in places you wouldn't expect. So maybe it's nuclear stuff, right? This can get very serious for national security. These are the challenges because you don't know where that data came from initially. So you can think of it as a bill of materials problem in some ways. So on the denial of service side, you can put in way too many requests for free services. That's kind of obvious, but you can also do this at a larger level. You need quotas and throttling. So if you are standing up a service, know that this is a very valuable thing. And even though it's brand new and everybody wants to put out something that's bright and shiny, you do have to be aware that it's going to be very popular. And secondly, these are generally very costly. And so even if the service continues to operate, it may be running up a huge bill with all the LLM queries going through if you're using a service that charges you per query. So if you didn't protect that, you may end up with a very large surprise bill and exhaustion of resources. On supply chain side, this kind of goes back to what's coming in. And this actually happened. We'll talk about some real world use cases here at the end. But an attacker can get into the actual supply chain attack for the LLM code itself. And the good news here is we already know about supply chain attacks and all the defenses we have against those do apply to this. But as we know from supply chain attacks, it's very difficult to nail it 100% of the time. Things do slip through. And for some of these very popular libraries like PyTorch, this can happen and we need to be aware of that. Similar to the poisoning, there's also sensitive information disclosure. Not a surprise. This one's, I think, probably what you would expect. But any of the training data could have sensitive information in it. If you sign up for ChatGPT, the very first thing it tells you is don't give me any sensitive data. I find that pretty funny. Still, they try to say they have privacy. They don't. They're still using all of that, and you need to be aware of that up front. And so the model implementers may have no control over where that comes from. They may, doing the training, you're training on existing data sets. And so it comes back to, do you know what data went into that data set when you start your training? And as I mentioned earlier, with specific models that you might build for something like a microbiology, that can be really important. I love the smiles on the faces that Stable Diffusion put for the insecure plugin design, because these guys seem to have a really fun time designing insecure plugins. Anyway, they seem really happy about it. I got a kick out of that one. So this is if you have a plugin that's going to call something. So we heard earlier about the playbooks, right? So make sure that the playbook has proper guardrails around it. I think this is the one that everyone is, it's the most upfront. I think people are most concerned about this one because it's the easiest to understand, which is an AI may say to do something that you didn't want it to do. And this isn't different than a rogue operator with access to playbook stuff. But it puts people in a difficult position where, well, how do I save time and use things like automated playbooks and then also trust the output? So the short answer right now is there isn't a good way to do that. So you try to get things to a place where a human can at least review it very quickly and then decide whether they're going to execute it. That's really the best answer we have today. I do see this as an evolving field. On excessive agency, I took this to be there's a line, and this person is about to cross that line, and that's the excessive agency as far as stable diffusion was concerned. But the person watching them doesn't seem to be too concerned with it, so I guess it's not that excessive. But yeah, I got a kick out of this one. So that's when an LLM has just too much power in general, and you gave it the ability to execute more commands. So it's similar to the previous one, but in a little bit broader context. And again, back to the human inspection, that's very expensive, and it really reduces the value. So this is one of the biggest problems right now. Over-reliance. So I guess the person on the lower thing is over-reliant to the person on the top of the mountain there. Assigning 100% of the initial incident handling. So being to say, well, I'll just let the AI do it. And this one, I think everyone initially is going to be guarded against, and I don't think there's going to be problems on day one for this because we're all sort of learning how much we can trust generative AI and LLMs, and so we'll have our guard up to begin with. I see this as a bigger problem next year as more things have Gen AI in them, and we're getting used to it being correct most of the time. This is where I see that showing up is you're starting to let your guard down and just say, yeah, we'll trust it every time. It's been right the last 10 times. I'm sure it'll be right on the 11th time. And that's when we're going to start to have the problems. So I see this as something that's a little bit further out, but still definitely a big problem. And this is my absolute favorite. I don't know what model this guy is stealing, but he has a really funny expression, and I don't know what object that is. I guess it's a cleaning thing, but apparently that's a model, and he's stealing it. So I don't know, but I love this one. He looks more surprised than anything that he's being caught or that what he's stealing. But anyway, I love that one. So yeah, the model itself, you can think of these as crown jewels, especially if you're doing specific training. If you're in fintech and you're doing financial modeling, this can be especially valuable. But saying we put all of the data that we know of, spend a ton of money, sometimes tens of millions of dollars to train these models, and then we're going to store it somewhere, and it's only going to be a few gigabytes. So this is something that attackers are definitely going to be going after because they're going to have a really high value. So that's something to note. All right, so these are the theoretical vulnerabilities, right? That's kind of, okay, great, yeah, we get it. There's some things that can go wrong. Here are the real world attacks. And so MITRE has done a great job of actually codifying all the attacks that they have seen, writing them all down. They're at that link. And I pulled out 3 of them here that I think are especially interesting. So you're all familiar with the MITRE attack framework. There's one for LLMs as well. And so you can go through each one of these and kind of map that back to the vulnerabilities that I showed. So on the supply chain attack, I alluded to this earlier, PyTorch, one of the most important libraries in generative AI right now, had a supply chain attack occur. This was a huge deal. And this was not that long ago, less than a year ago. This thing was completely owned through a supply chain attack. So this is not theoretical stuff. Next one down, so Kaspersky's red team, they did they used generative AI to essentially prove they could circumvent their own antivirus. They said, we can use this AI to figure out how to work around the machine learning based things that we've got and to essentially reverse engineer what it did. That was just, thankfully it was a red team, so it was sanctioned, it wasn't an adversary. But they proved out that, yeah, bad guys can definitely be doing this stuff. If they have access to the controls that are in place, they can ask AI, how do I circumvent these controls and codify that. And then lastly, coordinated attacks become a lot easier. So anytime you can generate content, you can weaponize the fact that you're generating content. So naturally, this corresponds to much better phishing emails, but there's also these real-world attacks on there was a product launch called Tay from Microsoft, and basically overnight they had to take it down because so many bots were hitting it, and they were using generative AI to make the content really, really hard to filter. So if you think about the 10 vulnerabilities I talked about, there aren't great mitigations because it's very hard to use things like regular expressions and rules to filter out content because this is all being generated. It's not something that's templated. That's really the big difference. All right, so top 3 takeaways here. First of all, LLMs are too valuable to go away. This is not a fad. As you saw just in the previous presentation, they're being worked into products everywhere, not just in security and everything. So they're here to stay, and we as security professionals need to understand what the potential vulnerabilities are and what to do about them. And even if you're not using them, you may still be affected by them because either upchain, they're having supply chain attacks, or you're interacting with them on a daily basis. And lastly, this is not theoretical. These things are actually happening in real time. All right, thanks. I'll be down here for any questions afterwards.